Don't worry. Okay, so let's take a look. We were doing some problems. I want to start out by reviewing a couple problems first. These two. So, as we were looking the other day, that's my. As we were discussing the other day, there we go. So the basic idea is you want to rewrite this number with a square on it so it can cancel out that denominator. That's the idea that we had last time. So if you recognize that this could be written as like 7 squared, and we raise that to the negative 3/2 power, then hopefully you could see quickly that this 2 here would cancel off this 2. And so that would give us 7 to the negative 3. And now to get rid of the negative exponent, we could use the elevator trick and rewrite this as 1 over 7 cubed like this. And I would venture to say that as long as it's not too cumbersome to do this calculation, that you should just go ahead and do it. So in this case, we would get 1 over 343, I believe. Okay. Any questions on this example here? Yeah.
What if the number you can't cube it at all, or like
Why? Why would you tell me you couldn't? Oh, you mean this step here? If you can't find a perfect square, then you probably will use your calculator. Okay. So on this particular problem, they give you directions to do this, evaluate this expression without using a calculator. So what they want you to do is use properties of exponents and your current knowledge to figure out a way to cancel out that denominator. So it's using properties of square roots and cube roots and nth roots and so on and so forth. So you're going to want to be familiar with these properties. The property here that when you multiply a fraction by another fraction, the denominators cancel, with the numerator. And then what to do with the negative exponent. You should move it down to the denominator. Okay. So you're illustrating that you know properties of, say, fractions, negative exponents, and so on, so to simplify this. The same is true with this one. What we'd like to do is cancel out that fourth root. So you know that powers and roots are inverse operations. So what power can we write this as so that it could cancel out that 4? If this is the fourth root. So what we're looking for is something to the 4th power. Well, it shouldn't take you too long to determine that 3 to the 4th power is equal to 81. You might have tried 2 to the 4th power, but first of all, these products are even, right? 2 times 2 times 2. So multiplying by 2's isn't going to give you an odd number, right? So you could probably eliminate that one quickly. And if you try other powers like 4 and 5, I mean, to the 5th power, this gets pretty big. I mean, 5 times 5 already is 25. You multiply by another 5, it's 125 already. And so you need the exponent product to give you 81. So you already know this is way too big. That to the 4th power is going to be an even number. So it shouldn't take that long to determine that it's got to be 3, right? And so it is. It's 3. And hopefully most of this math is the reason why we learn the times tables. You can do this in your head. It's like 3 times 3 times 3 times 3. Well, that's 9 times 9, which of course you should know is 81. So hopefully you determine quickly that this can be written as the 4th root of 3 to the 4th power, and then we have this raised to the negative 1. Well, this 4th, well, I shouldn't, it looks like 34, doesn't it? I'm going to rewrite that. This is 3 to the 4th fourth power, this fourth power here cancels this fourth root. So they cancel right there. So now you end up with 3 to the negative 1, which then is equal to 1 over 3. Okay? You couldn't think of it as a 1, but of course that's the same thing as 1/3. So those were the sorts of problems we were doing on the study guide. But there's one special type that you're probably not quite ready for. And okay, so we did some of those. I don't care to cover and review those. Those are pretty straightforward. Just put them in your calculator. But what about some of these equations? How do you do these? So the first step you want to do here is like any algebraic equation. You start to undo whatever's happening to x. And in this case, you have a 6 being multiplied. So we could get rid of the 6 quickly by dividing this side by 6 and dividing this side by 6. And after we do that step, we get x cubed is equal to 384 divided by 6. I get 64. Well, now, as I've been saying, to solve any equation, you have to do the inverse operation. The inverse operation of a cube is a cube root. So the next step we'd like to do is to do a cube root here and a cube root here. Well, so these are inverse operations, so the cube cancels off the cube root, which leaves me with x. Now the cube root of 64, we're looking for a number that would be cubed that would cancel that. And hopefully you could quickly tell that this is going to be 4 times 4 times 4, which is equal to 64. Okay, so then we could write this as the cube root of 4 cubed. And of course, in this case, the cube and the cube root cancel. And so you get x is equal to 4. Now, there's just one subtle thing you should realize here. When the index is odd, there's only one solution to worry about. If that index is an even number, we have to write plus or minus. Okay? So if it were a fourth root instead, then we'd have to write plus or minus here like that. Or if it were a sixth root, we would have to put plus or minus. Okay? And I think I've explained that before, but it's an easy step to overlook. Okay? Alright, so let's continue. This is a type of problem that a lot of people struggled with when they're trying to do their study guide. And I'll show you what a lot of people do, and it's incorrect. Okay? They do this. Oh, they see this 5 here. They say, oh, okay, this is x to the 5th minus 8 to the 5th. That's a bunch of BS. Seriously, people? You know what that 5 is telling you? It's telling you how many times this thing is multiplied by itself. Okay, so what it's telling you is that, oh, well, this is x minus 8 times x minus 8 times x minus 8 times x minus 8 times x minus 8. Now, I don't know about you, but I don't think there's too many people in our class that would like to multiply all this stuff out. And it's certainly not equal to this. Okay? Alright, so how should you do this problem? Well, what's the inverse operation here? Something to the 5th power, the inverse operation would be a 5th root. So why not get rid of that 5 by doing a 5th root on both sides? So the smarter way to go, I hope, you agree. I mean, if you insist, you can multiply this all out, and you could try refactoring it and all this other junk. It would be extremely annoying and cumbersome. Why not do a 5th root on this side and do a 5th root on this side? Remember, the 5th root cancels off something that's to the 5th power. So in this case, this would cancel off that. And look how nice this equation has become. Now we have x minus 8. Now, this portion over here, we would have to do in our calculator. And so we do the fifth root using our calculator, and hopefully you could try it also in your calculator and see if you get the same answer I get. I get this is equal to 2.51188643.2. Anyone else get that number? Yeah? Okay, make sure you can run your calculators just like in the last chapter when we're doing finance stuff. This stuff, you gotta be able to do. Now, are we interested in writing all this decimal stuff? Why don't we just go to the third decimal and stop? So, because this is an 8 right here, I think a smart move would be to rewrite this as x minus 8 equals 2.51, unless this 8 could bounce that up to a what? A 2? And so we'll do it like that. Okay, and now we'll just go basically one more step. We'll move this 8 over. I'm going to add 8 here and add 8 here, and I get x is equal to 10.512. Okay, so that's how we want to do these problems. Now, just again, one more additional point to watch out for. If this were a 4 instead, and a 4 right there, then you'd have a plus or minus right there. Okay? And so anytime you have an even index, you're going to have plus or minuses. Okay, I think now you should be able to do your application problems. And I just want to comment briefly on this problem. You should be able, sorry, I said application. I meant to say your study guide. You should be able to finish up your study guide and you should be able to do the book assignment. Yeah.
Plus or minus change the number at all?
Well, let's talk about that for a second. When you have x equal to 8 plus or minus, say, 5, it doesn't change any number. It just gives you two answers. So one answer is 8 plus 5, 8 plus 5, or the other answer is 8 minus 5. And usually in this case, since they're just numbers you could easily calculate, you then go one step further and say, well, x is equal to 13, or x is equal to 3. Okay, so the plus or minus is just a compact way of writing it. But it means this and that. Okay, so that's what it means. Well, hopefully that cleared up your question. Okay, so this type of problem here, this is just an application problem. Sometimes you have to solve equations. You have to solve surface area problems. Well, basically all you're going to do is put this number in here. That's your surface area, and then they want you to solve for the diameter. Remember, in a sphere or a circle, you have a radius that's halfway across a circle. If you go all the way across the circle, then that, of course, is your diameter. Okay? So basically what we need to do is solve for r and then double it. Okay? So on this particular problem, we're going to write 7, 8, 5, 4 is equal to 4 times pi times r squared, right? Well, we're solving for r squared, or we're solving for r, right? So why not get rid of this number, this 4 pi? Since these are all being multiplied, to get rid of them is to do the inverse operation, which is divide. So divide by 4 pi here, divide by 4 pi here. And be careful, you want to put this in parentheses down here. A lot of people make mistakes with their calculator. And I get basically 625.001 is equal to r squared. So the inverse operation of a square is its square root. So I would continue then with a square root here and a regular square root here. Remember, the index for a square root is a 2. Okay? Now, because that index is even, I should normally write plus or minus over here. However, on this problem, the context of the problem, we realize a radius of a circle can't be negative. Or in this case, the radius of a sphere. Can you have a negative radius? And so in this case, it doesn't make sense to have a negative. So in this case, we'd take off the negative answer because it's nonsense. Okay? So be aware of that. On certain application problems, you might have to eliminate one of your answers. And so let's just wrap this up. If you take the square root of 625, I do believe you get 25 here is equal to r. On this side, the square cancels off the square root. So we end up with r is equal to 25. By the way, there should be some units on here, right? The unit seems to be centimeters. So we probably should say the radius is equal to 25 centimeters. Now, is this correct? Whoops, let me back that up. Is that what we're asked to do? Actually, we weren't asked to do the radius. We're actually asked to find the diameter, I think. So let's just fix that. The diameter then is equal to 50 centimeters. Okay? Alright, so be paying attention to what the application problems are asking you. Those are a couple problems that we've reviewed now, and I'm going to give you the rest of the period to work on the assignment. So